Alright, so apparently my little cursor attention thing isn't going to work, so whatever. What we're going to be discussing today is multiple linear regression. And the book doesn't do a lot with it. You can take whole courses in this stuff. I think I took, as I said before in another video, which was about ANOVA, but ANOVA and multiple regression are kind of kissing cousins of one another. So the idea is that you're going to have something like y hat, that's a predicted value, is going to be equal to some. And now normally the big kids write beta naught. That's an intercept plus beta 1 x1. So this is the first variable, and this is its slope, if you will, plus beta 2 x2 plus dot dot dot, as many x's as you have. Okay, so I mean, you can think about a variety of things. You could think about, for instance, your blood pressure might be influenced by, well, everybody has some mean blood pressure. And if you're talking about American males, for instance, you probably want to separate them out by gender. And maybe there's a difference to, men and women have different blood pressures. So you can separate just, American male out. And then what could affect it? Well, weight, for instance, could. Okay, if you're overweight. Well, does that make it go up or down? Probably up. So this is probably a positive slope here, right? Okay. And then what about if your weight's 200 pounds, right? And then your average blood pressure for everybody's like 110 or something. So this can't be a very big number here if you weigh 200 pounds. It'd have to be like 0.1 or something, nothing too major. And then maybe stress level, and I don't know, 0 to 10, sure, 0 to 10, whatever. Well, as your stress goes up, your blood pressure goes up, so this is probably also positive. And then the number of times you work out a week, number of workouts, well, that's probably going to reduce your stress, so this will end up being a negative number here, probably in front of it, right, for the slope. So probably be a positive one here. Things like this are what's going to happen. Okay? Now, if we do this analysis and we find that, workout's not important, then we'll throw it out of the model and we'll come back with this. And then you're like, well, wait a minute. So you tell me you got a y hat, which is blood pressure, is equal to 110, let's say, plus, I don't know, 0.1 times your weight, plus 0.6 times stress or something. Okay, well, whatever. Maybe that's what I said. So then, what would the blood pressure be for a dude that weighs 200 pounds and is about a 5 on the stress level? Oops. So I'm sorry, 0.6 times 5 is 3. There you go. So this is 20. And 23, so you have a 133 blood pressure. And that would be a predicted value. Okay? That's the idea of what we're going to be doing. Okay? Now, when we do this, we're again, just like before, we're going to have basically a test. Okay, we've had a test on every single thing we've done this semester. Well, that's not wrong. And the idea here is that the correlation is not significant. Or if you prefer, the correlation is equal to 0. Either way, saying the same thing. And of course, it's not. And to test this, we're going to be doing an F test, but it's going to be very easy to do. Now, I've made up some data, and these are my y values. The big kids always put y's first, and then x's in that order. That's just how it's done when you get into upper level statistics. So data analysis, regression. So we're going to go and highlight our y values. So here they are. Oops. So, Then we're going to highlight our x's. And then we're going to make sure we click on labels. And then put an output range that's not in the way. So G1's nice, but it's not necessary. And then we're going to look at p-values, friends. Boom, just like always. Oh my gosh. How about that? Do you realize that taller people weigh more than shorter people on average? I had no idea. People with larger BMI, body mass indexes, weigh more? I'm shocked. Look at that. That's huge. Now notice, the intercept, we will never get rid of it, no matter what that p-value is. Well, I can't say never. In rare circumstances, but not right now. Okay? So what we're saying is the weight is equal to 0.44 plus 1.18 times height plus 5.99 times BMI. And you're like, where are you finding that, Jay? Right here in the coefficients. There they are. And then if you're asked, hey, can you predict for a fella that's, and by the way, I don't know if this is guys or girls. I'm not really sure. It's not really important to me. Let's just pretend here that it is men. I don't know because there's quite a bit of taller-ish people, but then there's also a few 5'8". So I don't know. I made the data up. You'd think I paid attention, but I didn't. I was just making crap up as I go along. So plus 1.18. So let's find out for a fella that is 70 inches tall, 70, plus 5.99 times the BMI, and this guy has a 27 BMI. So there it is. Now, of course, the computer's not going to figure that out, so you have to do it like this. Go equals 0.44 plus 1.18 times 70 plus 5.99 times 27 BMI. Boom. This guy should weigh 244. Okay? And that's our predicted value for him. That's it. Not very hard. Now on the next page, like, wow, blood pressure. Does it have anything to do with stress at home? Yes. Would that be a positive? That means, in other words, does your blood pressure go up as your stress goes up? Yeah. More than at work? Yeah, I would say so. Does it go up when you have stress at work? Well, yeah, obviously. And does blood pressure depend on whether you're male or female? I don't know. Let's find out. Now, you cannot do math with letters, letters obviously like that. So what we're going to do is we're going to use what's called an indicator variable. So you can do it either way you want to, male and female. So 0, 1 is how the big kids do it as a general rule. Okay, when there's two things. And so what I'm going to do is I'm going to highlight this column, only, Control F, and then go to replace, and I'm going to find zeros and replace them with males, or male. Oh, I'm sorry, I did the other way around. Try it again, dummy. Find male, replace it with 0. Attaboy. 1. There you go. And let's find female and replace it with 0. Or not with 0, with 1s. There we go. Oh, now, this happens once in a while when Jay doesn't pay attention to what he's doing. So it found male, all right. And it changed females to FO zeros. So you did not fool me, Mr. Computer. All right, there we go. And so there we have it. Now, if I did female first, I wouldn't have that problem. Life goes on. What are you going to do? All right. It is what it is. Thank God for undo, right? So there's my regression. So my Y's here are the blood pressures. My X's are all of these guys. All of them. Boom. Still have labels. True. I'm going to put my output range somewhere else this time. I'm going to put it down a little bit lower so it's not in the way of the female-male routine up here. And there it is. And let's look at our p-values. Look at our p-values. And so you're like, wow, stress at home is huge. Yeah, stress at work is huge. Yes, that's true. Oh, look at this. Gender is huge. Well, not so fast, Kimosabi. Look at that right there. That number is, in all intents and purposes, a big fat 0. In other words, it really doesn't matter. Okay? That's interesting. Okay? Now you're like, Jay, I should have paid attention to this F statistic right here, right? That's my p-value. This is highly significant, and that was true on the other page as well. Highly significant. But I come over here and I'm like, what? So in other words, basically this was 0, and it's not important at all. So gender is not important. And what you're going to find is that this is kind of embarrassing. Because what ended up happening was Jay, because he's an idiot apparently, decided that I forgot to add in I forgot to tweak my numbers a little bit. I got in a kind of a hurry. This is what happens once in a while. Times home stress plus 2 times work stress, and that's it. Okay? And again, gender is not important because, again, it came out to be 0 for the coefficient here. I mean, you could put 0 times gender if that makes you happy, but it's not important. Now, I'm going to do one. I'm going to tweak this actual data that I have right here for a moment, and I'll come right back to you. So stay tuned for more, and we'll get right back at you. Okay, so we're back. So what I did was, I got rid of the gender because that wasn't important anyways. And what I did was I went in and actually tweaked the data like I was supposed to have last time. What ended up happening was that I had actually made data, okay, and that's great. But usually what you need to do when you're doing that is you need to go back in and kind of randomize it, okay. And I didn't do that. That's why it came out so perfect. This is more like what it should have happened. Again, this is hugely important right there. That's a big deal. Okay. And then look down here. Because I randomized this blood pressure routine, look who's important now. Just stress at home. Stress at work is not important. And it's not important, so I'm going to throw it out of the model. I'm just going to start over. That's not important to me. If it's not important, why pay attention to it? So this time I'm only going to look at those two. Okay? So if it's not important, we throw it out of the model. So our y's are still the same, but now our x's are just stress at home. And I'll do this, and it'll say, do you want to overwrite? And I say, sure. And then lo and behold, look at that. It is highly significant, my stress at home. So my blood pressure is equal to 105.8 plus 6.9 times home stress. Okay, and there we go. That's how multiple regression always works. You're always going to be given a list of data where you have some x's and y's. Okay, and so you're going to run a regression. You're always going to look at the p-value, which is the significance. If it's significant, then come down here and look at these p-values. Don't pay attention to the intercept one, but look at the rest of them. If they are less than 0.05, hey, this thing is highly significant. Keep it in the model. If it's not, throw it out. And by throw it out, I mean run it again. Okay? Now, I will say, suppose that gender was important, but stress at work was not important. Okay? If that was true, what you're going to want to do is you're going to want to cut those out and move them over here in your model. So that what you end up with is the two x's that you're going to use are side by side. So that's the only thing that's a little weird, not weird, something you need to get used to when you're playing this with regression program that we're going to use in this data analysis regression tool, is that your x's must be side by side when you're dealing with them. So if you get rid of one of them, but it's one of the middle ones, it has to go. The two that you need, or three or whatever that you're using, have to be side by side by side. Okay? And so that's kind of a big deal there. Now, I've also, oopsie daisy, brought some over here to I brought a Google document up just for a look at it. So I'm going to copy all this. Again, it's exactly the same in Google, but just so we're clear, Control V, little add-ons, a little Excel minor tool pack. Down here you will see regression analysis, or regression, linear regression. There it is. Boom. So my y's are this stuff here. So now you got to do that and then click into here. That's great. Then come over here and highlight your x's, which are here, and now go click in the x range. Boom. Yes, I have labels. Don't need any of that business. The output range would be kind of nice to have. So let's put that in like F1 or something. You can stick it wherever you like. And that should be the exact same table we had out previously. Again, that's my level of significance. Here are my p-values, right? Notice, however, and it's quite possible that this will happen, is that in Excel, what we ended up with was it might have said something E minus whatever. Google just says, oh, screw it, that's 0. And that's fine. All right, just be aware of that. In Excel, this might have been 3.5 E minus 4 or 5 or something, whatever. I can't read without my glasses on. Over here, it spells it out for you. Okay, just be aware of that. Same thing up here. In Excel, that was 7.5 E minus something. Over here, it's 0.00000. It's possible we'd have such a small one that this would just say screw it at 0 as well. In either case, it's less than 0.05 and you're done.